Hello, in our last video we discussed polynomial division and we discussed some basic form of polynomial division, and we even did an example of a polynomial division problem. And in fact we determined that x squared minus 5x plus 6 all over x minus 3 equals to x minus 2. But now I always like to get into what does this mean? What is the meaning of this division? So some of you may recall factoring. So some of you may recall factoring. I always like to make the reference about how factoring works. So if I were to set a function equal to x squared minus 5x plus 6, we could factor this and we could say that f of x equals to x minus 3 times x minus 2. And notice here, that's exactly what we got. We said that when we divide x minus 3 into our polynomial x squared minus 5x plus 6, we get x minus 2. And remember what happens. When we set this equal to 0, we are able to determine our zeros. So we're able to determine our zeros. So we get x equals to 3 and x equals to 2. So these are our zeros, and some of you might even make reference back to the multiplicity. And yes, the multiplicity of these zeros are a value of 1, so you're thinking the multiplicity is odd, so it's going to cross, the function is going to cross the x-axis at 2 and 3, and you would be correct. So at 2 and 3, our polynomial opens up because the leading coefficient is positive. And that's a horrible polynomial, that's a horrible parabola. So it's going to open up, our coefficient's that's a bad parabola as well. There we go, a little bit better. There we go, it's the best I can do with my sturdy tool here. So, so we recognize that we cross here. So let's talk about what this means. What does it mean? So let's discuss the meaning of polynomial division. Meaning of polynomial division. So specifically, in this first example we did before, we were testing something. And what we were testing is whether x minus 3 is a factor that divides evenly into x squared minus 5x plus 6. And now what do we mean when we say divides evenly? What does that mean? And remember, this means that no remainder exists. So no remainder. So if x minus 3 divides evenly into this polynomial, we know that no remainder will exist. And I think we remember doing this a couple of seconds back, or depending on when you watched the video, however long back you watched it, that there was no remainder. This one in a perfect amount of x minus 2 times. So what does that mean? That means that x minus 3 is a factor. X minus 3 is a factor. And x equals to 3 is a 0 of the polynomial. X equals to 3 is a 0 of the polynomial. Since x minus 3 is a factor and it divides evenly, then x equals to 3 is a 0 of a polynomial. So ultimately what we're doing graphically and even algebraically is that we're testing whether or not the factor at the bottom divides evenly, and if it does, when set equal to 0, we're able to determine the 0 of the polynomial. So let's go on and analyze another example of a polynomial division. So let's go and analyze x squared. So let's go ahead, and I can come up with these usually pretty quickly. So we'll say minus 5x plus 14 all over x minus 7. So let's think what we're testing. So let's analyze what we are testing. We are testing whether x minus 7 divides evenly into x squared minus 5x plus 14. That's what we're really testing here, is whether it divides evenly. And if the answer is a yes, if it's a yes, then we know that x minus 7 is a factor, and x equals to 7 is a 0 of x squared minus 5x plus 14. If the answer is a no, and that's a 14 out of 19, 14. If the answer is a no, and it does not divide evenly, if it does not divide evenly, so x minus 7 is not a factor of the polynomial, x squared minus 5x plus 14, and x equal to 7 is not a zero, So ultimately this is continuing with our zero analysis. How do we determine the x-intercepts and how do we determine the zero? So if it divides evenly, then we have a 0. If it doesn't divide evenly, then we don't have a 0. And why is this so important is that ultimately we're going to get to something called synthetic division. So it's imperative that we understand what exactly we're doing so that way we can execute our synthetic division, which we're going to learn in a future video. So we have to make sure that whatever we analyze with synthetic division will actually work. It makes a lot more sense when we know what we're doing and not just memorizing a process. So let's go ahead and analyze or divide x minus 7 into x squared minus 5x plus 14. Plus 14. I'm going to stop choosing 4s. So the first thing we're going to say to ourselves is what times x gives you x squared? And hopefully we all recognize that's a value of x. We're going to take our x, we're going to multiply it times x minus 7, multiply it times the entire divisor. So we're going to get x squared, and x times negative 7 gives you minus 7x. But remember, what we have to do with this is that we have to divide. So we're going to use some bright colors here. So that's actually 2 that clashes. Let us try brown. So we're going to have to subtract. We're going to subtract the entire value. So that makes this a negative x squared, and that makes this a positive 7x. So that will give us x squared minus x squared gives us a value of 0. Negative 5x plus 7x gives me a value of positive 2x. Positive 2x. And then I'm going to bring down my positive 14. I bring down my positive 14. And now we start from the beginning. We say what times x gives you 2x? That's a value of positive 2. And we're going to take that 2, multiply it times that x minus 7 again. 2 times x gives me 2x. 2 times negative 7 gives me negative 14. And now we're going to subtract. We're going to subtract this value. We're going to subtract these values. So now when we subtract these values, we are going to change our signs. So I have to subtract, and I'll subtract in gray again. Where's my gray? There it is. So I'm going to subtract. So I change this sign, then I change this sign, and I change this to a positive. My 2x and my negative 2x cancel, but notice I get 14 plus 14, which is a value of positive 28. So here I get a remainder. A remainder. So since my remainder is not equal to 0, therefore I know I would write this thing, my inner third grader, as a positive because my sign is a positive 28. I want to write plus or minus, but my sign is a positive. And I take my 28 and I divide it by my divisor, which is x minus 7. So since it does not go in evenly with a remainder of 0, we know that x minus 7 is not a factor and x equals 7 is not a 0. So we will not have a yes outcome because we don't have a remainder of 0. We know that it will not work. And most of us might have made the mistake. We might have said, oh yeah, this equals to x minus 2, but it wouldn't be minus 2 because we would not get the exact same thing. So again, this was not divided evenly. So we would say actually our answer here would be x plus 2 plus 28 all over x minus 7. And we know 7 is not a 0 of our polynomial.